Welcome everyone to our plenary session 7, if I remember correctly. That today we're going to focus on the discussion about integrated and interdisciplinary AI development in environmental science. First of all, I want to say congratulations to everyone who have made through the week. It has been a busy week for many of you, and thank you for all your support for the entire workshop duration. And we cannot do this without you. And before we go into the meat of discussion, I want to again remind everyone, so hopefully everyone remembers the code of conduct for the events, but in case we have newcomers for this plenary session, we want to make sure that this event is safe, productive, inclusive, and welcoming environment for everyone. So if you are experiencing any unacceptable behaviors, please let the planning team know at ai.workshop and NOAA.gov. So the whole session originated from a discussion that some of the planning team members have, which is how we can make sure the development of the AI applications is inclusive. Originally, our thought is that we have domain scientists, we have user, and we have AI developers in this cycle. But so as you can see in different type of life cycle portrayed in the different articles or different documents that always start from problem definition to data to model to production. But a lot of times that we think the discussion around the AI development lifecycle often lack humanity. So we do not really talk about who are involved in this process. And throughout this workshop, we have heard so many different questions around the similar idea, which is this lifecycle complete? So who we should include in this life cycle. And one topic come up was communication of the risk of the AI applications. So when the communication parts feed and how does feed into the life cycle, should be in a specific step or should be going through the entire process. And another question we have heard over and over again is who and how many groups should be part of this life cycle. And another topic you probably heard several times in different plenary sessions is should we bring AI machine learning to domain scientists or bring domain scientists to the AI and machine learning developers? And some people will say neither or both. So how do the social science fit into this life cycle? So that's the whole background of this panel discussion. We want to bring the humanity back into this life cycle development. So we have an awesome panel here with 5 panelists, and I will be moderating this panel together with Rob, my co-chair of the workshop. And if you have any questions like all the other plenary discussion, please submit your questions at Slido using the code NOAA 2021, or you will use the link that being posted by the LOC members in the chat. So as I said, we have 5 awesome panelists today from Bostrom, who is also on our planning team for this workshop, a professor from University of Washington. We have Julie DeMoose, from a project scientist from NCAI, is also on our planning group. And we have Lakshman from Google Cloud, and we have Jeb Storr as the co-chair of the NOAA AI Executive Committee. And he has also been the chair for some sessions that you may already seen him. And we have Rose Hendricks, who is with Allen Institute for AI, or AI2. And without further ado, I'm gonna go into the slides from our panelists by inviting them to share their perspective of what they think should be included in this integrated and interdisciplinary AI development lifecycle. And I believe you are the first.
I will be first.
You are the first, yes.
Yep.
I need more coffee.
I think we all do. Well, thank you so much, Douglas and Rob, for even thinking about holding this session and for bringing us all together. I'm really looking forward to this conversation and to the questions that come up. So I have a couple of slides. And the first thing that I wanted to start with was to provide perspective on this idea of the topic of integration in general by drawing on and discussing kind of these ideas of interdisciplinary or convergent research. and showing some other examples in the community where this has been thought about. And so this notion of convergent research has been defined by NSF, and it has two key components, which you can see there. The first one is that it's research that's driven by and addresses a specific compelling problem that comes from these deep scientific questions or pressing societal needs. And I think everything we've been talking about this week at the workshop certainly meets those criteria. But it also involves deep integration across disciplines. And I love this part where the knowledge, the theories, the methods, and the data become increasingly intermingled or integrated. And so I think those ideas are really important. And the image in the middle of the slide is from a paper by Lori Peek and her colleagues. And it is meant to conceptually represent the deep integration of convergence. So that idea, I'm sorry, the whole thing, it conceptually represents this deep integration of convergence. So the image on the right is really what shows this intermingling of the knowledge and ideas. And here I love how that does come together and how it's contrasted with the image on the left, which really depicts research that has multiple disciplines, but that work in parallel without really coming together. And then on the right is a table from a paper that just recently came out that really talks about how to do the within interdisciplinary research, and that discusses signs of successful interdisciplinary work. And all these signs are important, but I particularly wanted to highlight this idea that really resonates with me, which is that a sign of it is that we're generating novel research questions or identifying novel problems. We're doing novel approaches, we're doing novel interpretations as compared to, again, if we just had different disciplines that didn't come together to shape something new. So I just wanted to provide that background. And if you can go to the next slide, Douglas, I wanted to talk about this a little bit more concretely. So I wanted to provide a sense of kind of the more nuanced and complex and multifaceted aspects that I think we need to consider when we think about doing kind of this integrated or interdisciplinary work that creates trustworthy and responsible AI. And I'm going to put a lot of stuff on the slide. I should note that these ideas aren't meant to cover everything. They're really just meant to be illustrative. But the first component, I think, is this question of what. And by that, I mean, what is a more concrete but still broadly encompassing goal? Or to use your words from a few minutes ago, Douglas, like what is the problem or the problem that we can define? And here I've offered on the left-hand side a more user-oriented perspective, which is that we want to understand how AI guidance is accessed, how it's interpreted, how it's perceived, how it's needed, and how it's used as people are assessing the risk and making a decision. And this goal needs to be iteratively and in an ongoing way coupled with this other goal of developing physics-based, robust, or trustworthy AI guidance for weather, climate, and coastal hazards. And I think there are many more specific R&D questions or problems that can be addressed under this umbrella, but I think framing it this way helps scope it a little bit more and gives us something more concrete to hook into. So if you can animate, Douglas. The second component here is who should be involved. And this question has come up repeatedly this week and many conversations before that. And the answer is there should be a lot of people, including researchers and practitioners, people from across sectors, public, private, nonprofit, and academia. And then many different disciplines or areas of expertise need to be included, including from the social sciences, risk, decision, policy, and other social sciences, AI and XAI, and all the different disciplines that fall within that, atmospheric and environmental, and information and data science. And they all need to come together in different combinations, in different ways, different degrees of overlap, and at different points in the process, and often iteratively. And if you can go ahead and animate the last part here, Douglas. The third component here is really how do we think about doing this kind of interdisciplinary research? And there's a lot here, but this is meant to show some of the multifaceted nature that is really based on the work that we're doing as part of the NSF AI Institute, AI2ES, that Anne and Jeb and I are all involved in. And this still doesn't even capture all of what we want to do. But it's important to think about the diversity of hazards, severe, winter, tropical, even other hazards, and even the diversity within them, because if you have severe, you have tornadoes, you have hail, or if you have hurricanes, you have many different kinds. Something like a Harvey is different from an Irma, which is different from an Ida. So recognizing that we need to study across all of those hazards and the heterogeneity within them. There are many different users. They have different roles in different jurisdictions, and they make different decisions, and those are constantly changing. And what we've opted in the AI Institute is to focus on professional users versus members of the public, not because the public isn't important and that needs to be done, but because these professional users are closer, more direct users of AI guidance, and they make decisions on behalf of society. So we wanted to really study them and work closely with them. There are many different AI and XAI techniques that provide different kinds of information and that raise different questions about explainability and interpretability. And then last but not least, because I think this is such an important point, research with users, I think, often tends to get thought about kind of in the last mile, or maybe even now we're broadening that frame, but still kind of farther along in the development process. And it is important to do research with users at that stage, but it's also really essential to involve them earlier in the more basic or formative stages, especially if that work can elicit new kinds of information that they need that aren't being considered or that are developed or that are under development already. So it's just, again, the emphasis that we need to be doing this research with users at all phases. So with that, I'm going to stop and I think hand it off to Anne, who I'm sure will complement these ideas.
Great.
Thanks,
Thank
Julie.
you. Thank you, Julie. So I'm just going to be elaborating on some points that Julie has made. Know your audience is a first principle of risk communication, yet it's challenging to achieve in most contexts. For example, this type of context. Each of us brings our own perspectives and mental models to bear when we hear terms like trustworthy AI and consider what it means to achieve responsible and trustworthy AI applications, or what it means to involve all parties in the complete application lifecycle. Next slide, please. Know your audience is a first, at least 4 types of factors influence users' trust in AI models: user characteristics and mental models, mental model accuracy itself and verification, the work context as practice, which may not be as imagined, as Dr. Roth pointed out in her plenary talk earlier this week, and explanations. Poor explanations, such as low fidelity explanations that only highlight features of input data and don't provide information about what is influencing prediction, can decrease trust in an AI model. Each of these implies a different study strategy and type of scientific expertise. Mental models have been studied extensively in science education, for example, and in judgment and decision-making by cognitive psychologists and anthropologists, with diverse methodological approaches. Mental models have been studied by risk perception scholars as a basis for designing risk communications, as Julie and I are doing in the context of AI2ES. Metrics for model accuracy and reliability and predictability vary, and some may be preferred over others, depending on their statistical properties and how these correspond to what people value. So they can differ by who it is who's doing the valuation. And with regard to the context for AI use, anthropologists, sociologists, social and organizational psychologists, and cognitive engineers are among those who have studied work practices and places using a variety of strategies, from ethnography to survey methodology and task analysis. And fourth, the perception, construction, and communication of explanations have also been studied by social and behavioral scientists with diverse training and expertise, and have been a topic, for example, in philosophy. Next slide, please. The choice of users to engage in AI development is consequential. This graphic portrays what might be called a socio-ecological perspective on this question, after Bronfenbrenner's work in the 70s and 80s and beyond on the socio-ecological framework, which situated individual decisions and behavior in their environment to examine how human development is shaped by the interaction between an individual and their environment, from family and friends at the micro scale, through informal and formal social structures such as government at the exoscale, and institutions, ideology, and norms at the macro scale, with a chronological trajectory of environmental events and transitions shaping the life course. In a very loose analogy, as this graphic shows, the use and consequences of AI vary in their proximity and interactions with the science and models, but these are contingent, layered, and may increase in their consequentiality at each remove, suggesting that there's a need for systematic research on all of these users to assess influential knowledge gaps and inform AI development. And as Julie mentioned, this shows where we've chosen to focus in AI2ES, which are at some of these intermediate layers that mediate what's happening between the science and the users. Thank you. I believe it's over to Black.
This is my slide. So I am coming from a slightly different context from a lot of this panel, where I am on the applied science and technology team at AI2, and I primarily work on activity analysis. So I work with environmental data, but I'm not directly producing environmental data. And I just wanted to talk about another perspective on integrated AI, which, for a working definition for me, it's something that in some sense has to live on after the life of the project, and it has to live in the wild and maybe get users that weren't part of the development lifecycle originally. And so the important part about this is that the development of a AI model or any model of any kind has a particular context. And for integrated AI that will live on and maybe be applied to different use cases that weren't originally considered, it's really important to be transparent about the context of the training data, because that model is going to be trained to that context. And if you are then applying it outside of that context, it might produce things that are unexpected. And even if they're not considered errors in a sense, it's important to be able to communicate what is expected behavior and how that ties to the context of the training data. And then the other thing is to, when talking to users, a lot of stuff in here is talked about professional users, and that's certainly relevant, but it's important when working across disciplines to talk about acceptance criteria and what kind of performance is good enough. And it's really important for AI practitioners to really get in the nitty-gritty on what performance means, because again, tying it back to context of your data, that you can only evaluate your model against data that you already have. And so in some sense, your performance criteria are also tied to the particular context you're working with when you're developing that data. And that's not a problem, but it is relevant when that model has to live on into different times, different regions, different kinds of things. So being more deliberate about sharing what particular metrics mean and what they mean in the specific context that they were originally developed in, I think is really important for this concept of integrated AI. That is all I had to talk about.
Thanks, Rose. And I will pass it to Lack. Do you have a slide, Lack?
Yes. Could you just reload, maybe?
Okay. Here it is. Sorry, I went too fast.
Okay. No problem. Yeah, I mean, great points by everybody on the on the panel when Julie talked about the phases of the context, the phases of the project, and basically thinking about early projects versus production projects and how we need to think about user trust and how that also depends on the context in which you're talking to the user. But one thing that I want to raise is that by the time the model is created, it is way too late for you to basically add interpretability, right? Explainability are not things that you bolt on to the end of a model. So when you think about the typical machine learning lifecycle of gathering and pre-processing data, building ML models, running training and evaluation, and then you deploy the model and you use it to make predictions, the problems associated with trust and interpretability occur early on in the life cycle. So if you wait until you have created a model and you say, okay, now that I'm surfacing the model to end users, let me go ahead and add an explainability AI method to it, it is way too late. No. So like, what do you mean by that? Right? When you're gathering data, there's all kinds of data set imbalances that you will be identifying, that you will be correcting. But the way that you're representing that data itself could be biased, especially if you're taking into account human behavior. Let's say, for example, you're training an ML model that takes into account how people reacted to a weather warning. That is going to be highly context dependent, and it will reflect a lot of biases in the way that we have built cities. If you think about creating ML models, the feature set that you're going to be using, it's not just going to be limited to your weather data, but it is going to involve a bunch of other information. And the way that you observe and what you choose to observe is going to be problematic, because there's going to be all kinds of proxies that you're using. Especially, like, for example, if you take data that has been, you take satellite data and you've done parallax correction on it, if you take radar data and you remove ground clutter from it, those kinds of pre-processing methods involve basically adding biases into the model itself. And then your modeling technique itself, because you're adding like outlier detection, if you're basically using an ML model that is not expressive enough, it may not capture a lot of the nuances of the data. When you're trying to start running your training and evaluation, the way that you run your evaluation is going to matter. Are you evaluating over the entire data set? Are you evaluating on slices of the data set? Are you taking into account fairness rules when you're basically evaluating it? Should all slices of the population be treated in the same way? Now when you talk about explainability again, the way a model behaves locally and globally can be very different. And here, locally and globally refer to not geographic locality and global locality, but local and global from the explainability sense. Are you understanding the model from the perspective of a single prediction, or are you understanding the model from the perspective of overall feature importance, for example? Those matter as well. So the point I'm trying to say is that basically trying to create a model, assuming that your data set is the same, that your models are the same, are not changeable, it may not be the right approach. You don't want to have this view of a static view of the entire ML landscape. Instead, you want to think of all of these aspects as potentially changeable in response to user feedback. So when you surface a prediction to end users, you want to get the feedback, you want to see how it works, and then you want to be able to basically walk that back and change each of the decisions that you have made when you're creating the AI models in the first place. But that poses a huge problem because of the way technology transfer is done today at NOAA, right? So you basically have research units that research the data. They basically get data on research units that basically create ML models. You have operational units that create the data without any regard for how those things are going to get used for modeling purposes, because the purpose of creating data is to make operational decisions. And now those research models are then transferred over typically to contractors, and they then go ahead and implement the model. And at that point, the whole thing is very, very, very static. This idea of a feedback loop with continuous improvement in response to local behavior, in response to bad behavior on individual instances is something that we have to think about. So when we think about, we want to add user trust, especially when it comes to things like AI, you also have to think about your software delivery lifecycle. How it is that we basically build production algorithms and production decision guidance at NOAA today, and how it is used by operational forecasters, and how it is disseminated to the public.
Thanks, Lak. And while Lak already called out NOAA, so I guess the last speaker, Jeff, maybe can close out this first round of discussion or share your perspective, and we can move on to our more freestyle discussion afterwards. Jeff?
Sure, thank you. And thanks to everyone. Yes, and as the person who gets to go last, we've already covered a lot of things I'm going to say, so I'm glad I didn't prepare slides because it'd be a lot of the same material we have seen earlier. I do work at the Global Systems Laboratory, so I'm coming at this from a research perspective. And I like this idea of these different contexts. We have a lot of different contexts in how we work with this whole AI development pipeline. From my perspective, for a lot of the groups we work with, we are scientists. We think like scientists. We discuss and talk like scientists. We end up with products like AUC, ROC, a lot of very technical terms. While some of our users do understand these terminologies, there's a lot that gets lost because it doesn't really relate to the problems they are trying to solve. And so I like this idea of keeping the end users in mind. We talk a lot about this with the transitions, the research to operations, research to applications, the research to commercialization. Having the end user perspective in mind is very important, because if they don't understand what we're producing and how we're producing it, it is not that useful for them. I also like the perspective here that we're not and no one is an expert on all the things. We have the data coming in, the data is processed, it's delivered to our doorstep, then we use it. And so having a data scientist that understands some of the data, the nuances of the data is important. Having our AI experts, our domain experts who can apply machine learning to these data sets. They have their own context, their own views on how things should work. It's very important, in my perspective, in the research arena, that we have these groups working together, because I think we each bring unique perspectives on this, but we don't have all the answers. We need, I think, also the social scientists. You know, that's a big part of this conversation here. We can ask questions, but I don't know that we're asking the right questions to our end users. How do we want to fine tune what we do, what we're producing for our specific end users? I think, there's another important aspect there. So this is the part of that knowing your audience. I think trustworthy AI is a big part of this interdisciplinary approach here. We see this across this entire AI development ecosystem. LAC talked a lot about the data. We need to know the data we're working with. Is there any inherent biases in this data? Does it represent the problem we're trying to solve? We have seen in the past, you know, models that are developed on a very limited set of data, and they don't do a good job of extrapolating, or they don't do a good job of moving on when they start to handle new observations as they come in. We need to know how our AI models are performing, what they are telling us. This brings in the ideas of the explainable AI. Linking back to data, can it handle evolving conditions? We heard a lot of conversations about climate. We know climate is evolving. Our data may or may not represent how that is changing. And so can our models, our AI developed models in this case, handle this changing environment? And then, you know, the last part of this, not necessarily the last part here, is, but how do we work in the context of our end users? Our AI models tell our scientists something, but it depends on what our end users, the people who are using this, the impacts and hazards they're trying to work with, what their context is. And so how do we convert what an AI model is telling us into something that's meaningful to our end users that can then turn that into something actionable, whether it's decisions or other things that the end users need the data for. I think there's really, you know, working together as a team here is very important. Bringing those perspectives in helps the trust, helps these AI models be used in the real world. And my biggest question, and maybe this will come up in our panel discussion here afterwards, is the how. So we did, you know, our funding is separate. Our funding is targeted for specific cases. I'd like to hear perspectives on maybe how we can be more interdisciplinary, bring together these different experts across the spectrum to make this happen. So that's my closing argument or closing question. Thank you.
Thanks, Jeb. Thanks for all our 5 panelists already provided such incredible perspective. And I'm gonna invite Rob here to ask our first question, which is, we already have curated this specific question, but all other questions will be mostly coming from the audience. Rob, please go ahead.
Yeah, let me go ahead. But you know, what an incredibly convergent set of perspectives with also your own independent experiences. It really speaks to Julie's need for deep integration of interdisciplinary expertises. So I'm going to, as Douglas claimed earlier in the week, if we take a risk and let's sort of combine 2 questions. We have the curated one, but I can kind of add a little bit of one that we're seeing pop up in Slido too. So, so you talked a lot about capturing from the users, and I really love what Jeb said at the end, in a sense. How do we learn to ask users the right questions, and in order to meet their needs, like actionability and decision making? And then how do we build, so I'm thinking now on all Locke's ideas too, how do we build trustworthy things with evolving climate and environment? So here's the question, kind of framing it that way. Here's the question: how do we do more to communicate the complete process from input data, development, to results of AI applications? And how do we capture user feedback to inform research? And part of that capture, linking to Slido here, how do we share what didn't work? So I will, if anyone wants to step forward first, you're welcome to. Otherwise, I think I will make a suggestion, but I'll pause for a second just in case.
Yeah,
Go ahead, Locke. Looks like you stepped forward.
Okay. Yeah, I was going to say that now thinking in terms of we're going to basically develop the models and then we're going to get the user feedback and incorporate it into research sounds like such a slow and weighty process. This is not that is not the way that, like, especially if you're going to be talking about AI and we're going to be talking about personalized guidance. This idea of aggregating user feedback completely cuts against the grain that the decision guidance that we've been giving is so personalized. But then what we're going to do is we're going to aggregate everybody's feedback. In other words, we're going to depersonalize all of that, and then we're going to basically again solve it from the overall perspective. If we're going to be providing personalized guidance, we need to do personalized adaptation of the models. If I'm a person, right, who lives out in the country and I have a very high sensitivity to wildfire risk, and I want to basically get my decision thresholds are much lower for wildfire risk, I think NOAA should respect my decision threshold and not basically combine my feedback with like 1,000 other people who don't have that decision threshold.
That's a really good point. So do we have a second person who wants to go?
I can, maybe I'll prompt Julie or Anne to jump in here, but I think this idea of asking the right questions is an important thing here. And if we look back at when the cars were first being developed, you ask people what they want, I think there's some quote that's like they want faster horses or more horses. And that doesn't work in the spectrum. So asking the right question, getting to the bottom of what they want is an iterative process. And so we need to go to the users, we need to ask a bunch of questions, we need to look at the results they give us, but then also go back to them again. And so I liked Anne's graph with the circles, and there's, I think Julie also had something where there's an iterative process here. We need to involve and talk to users often and keep asking different questions, because I think even if they're looking for the same result, different questions might get different answers. And so in this, I think goes to what Lack was saying, is that the context is important. People are interested in different things. And so really hard to ask the right questions. And how do we do that is an important aspect of some of this research.
Maybe I'll jump in here and follow on that. Thank you both. I'm very enlightening perspectives and enlightened too. There is this question of whether you can develop anything that's trustworthy without some kind of interaction. And so thinking about what Lack said, there's a tension always between making something interactive. So can you set your own threshold, for example, for the risks that you're willing to tolerate in the output from the model? And that's a very important concept that's controversial in a lot of communication context. The other idea is that people don't truly understand something unless they interact. And so if you want to develop something, you want to develop it with the other people who are working on it. It's this idea of a personalized development process even. And there's a tension of that against the scientific perspective, which requires a systematic approach, which might implicitly be construed to mean that you're aggregating opinions. So you want to do a scientific process, but you have to realize that you're going to have to start in the small picture, basically, if you're in the development process.
And I guess I'll jump in too, just to add to kind of what Anne and Deb and Lack already talked about. I mean, to address, also going back to your question, Rob, is I think a couple of things, that kind of knowing what are the questions that we ask. I mean, there's a whole bunch of literature that's out there, both in the social sciences, but also that's been done like in the domains space that we're interested in. So work that has been done with forecasters in the context of hazardous weather or climate or coastal hazards, work that has been done with emergency managers, work that's been done with other users to give us some sense of what is their decision context, what is the decision space, what kind of decisions are they making, at what lead time. So that kind of helps us frame some of those questions. And then we can draw on the social science literature, like Anne talked about a lot of different disciplines disciplines that helps us understand, some of the factors that shape how people get information, how they perceive risk, how they make decisions, what other factors are key in that entire process, how policy, how barriers, how recent effects, how heuristics can all shape that. And then if we couple that with what the AI community is trying to do, like what are some of these features, for instance, of explainability, that's how we shape the questions that we ask. I think this other question of how we can share, I don't think any of us touched on this, Rob, about how we share, or maybe Anne started to, what hasn't worked. I think there's a couple of ways. I mean, this is, a very pedantic way, but it's true, is, we can have hypotheses that we test and we report if we actually didn't find what we thought we were going to find going in. I mean, that's a really key way that is in the research design process. I also think, I'm going to draw on an example here that's sort of adjacent, but I think it's relevant. Not necessarily AI specific, but we have done work in the past where we've had to collect and curate Twitter data so that we would analyze it to understand kind of how people were, facing a hurricane, how they were perceiving their risk. And when you're dealing with Twitter data, it's a lot like any kind of AI data. You have to make choices about your sampling. And we made choices in a lot of different ways that didn't pan out in the ways that we thought. But when we went to write up that paper, we reported all the steps, including what didn't work and including like how we managed to funnel the data into something that's useful. I mean, I think it's just a purely reporting of the methodologies, including the stuff that didn't work or why it didn't work or why it didn't, to touch on something Jeb said, why it didn't match what we were trying to get at. And so how we have to iterate in that process to be able to answer the questions that we're interested in.
So thank you so much, Julie. Yeah, Julie and others, and I have a seg to Rose too. I think that, the language of talking about failure is always tricky, and I really appreciate your taking that as efforts. And I think that maybe we all have to work together to, inspire editors and inspire the places where we do publish to want that information and appreciate it and motivate its capture. So Rose, you said some great things about capturing performance and tying it back to the data. And I wonder if you could close out this question, if you wanted to close out this question with some comments.
Sure. Yeah, I would love to. I will say that capturing that kind of feedback that tells you something that is meaningful and actionable, it's really challenging, especially if you are working with users who are not in your discipline, either because they're lay people or because they're working in a different scientific field. And that is a great reason to have interdisciplinary teams, is that I don't get to talk to users that often because I tend not to ask them very useful questions, because it's just a really easy trap to fall into where you are framing the feedback you get by the questions you ask. And so being able to talk to users in a really open-ended way is a lot more work, but it's really important when you're first starting out to understand that you are actually solving their problem, and you are not solving something that is related to their problem, but something that is more tractable, or it fits better in a framework of something that you'd worked on before. And it's really, really important, and it's really hard. And it's not necessarily a skill that is aligned with the technical capability of building it. And so that is a really compelling case for having interdisciplinary teams and having social scientists who are better able to get at the meat of what users really need. To tie it back to reporting failure, there's sort of two parts to this. So on my slide, I talked about how to talk about model acceptance criteria and like what it means, because no AI model is going to have perfect performance. Users would love that. It's not going to happen in practice. And so being able to communicate expected failure cases, unexpected failure cases, again, the context of your data so that users can understand to a degree, all of this data was captured in the Northern Hemisphere, and then I am working in Australia. Maybe there's some differences there, something like that. In terms of reporting failings outside of a project, I think that really is the $1 million question, because that is saying, I would like to change the incentive structure of academic publishing. And that's really hard. I think that if a failure can be married to a narrative of, and then we tried this other thing and it worked, then I think that it has a much higher chance of getting into an academic paper. But if people tried something and it just did not work at all, that generally isn't going to see the light of day, because no venue is incentivizing that. And so I think that it would be incredibly useful for science, but I don't know that anyone solved that problem, even though a lot of people are interested in it. That's a little bit depressing, but I think that's where I'm at on that.
Thanks, Rose. I think you're, sorry, Rob.
Thank you, Rose. No, I just wanted to give the mic to Douglas. Sorry for stepping on you there.
No worries. I think Rose and Jude already touched on the topic that I'm going to ask next, which is highly voted in our Slido, relates to the failure topic. And that is also a question like dear to my heart. Last year, we organized a session during AGU, specifically sharing about the experience of promoting normalizing the discussion around failure. And Rose already touched on the selection bias in terms of publishing the results, because we all publishing successful results. A lot of times, the failed attempts usually don't get covered in those public venues. So this question was, and this question just disappeared, but I can rephrase basically as just asking that how we can incentivize that and to share those failed attempts. I think it come back again. So journals and conferences are great for presenting successful results, but I think a lot of times it's wasted in repeating unsuccessful approaches that have already been tried and rejected by someone else. So how can we promote that type of share and normalizing discussion about the failed attempts? Maybe it's in Google team, or maybe it's in the AI2 team that you already tried something that doesn't work. And for some new early career scientists, they come into this topic and we don't want them to repeat the same failed attempts, and they can spend their time more efficiently in other topics or other ways to make things more successful. I think Julie and Rose already touched on it. So maybe I would start with Anne, Lack, or like Jeb. Who want to go first?
Sure, I'll just jump in quickly. I'm just thinking about the standards for how you publish studies differ across disciplines. So in psychology, one thing that happens that might promote reporting failed attempts is that you report multiple studies in the same paper. This is a different kind of process for people. So like you might have five studies in a set where two of them try something that didn't work, and then you have, as Rose suggested, you couple that with something that worked slightly better. That gives you the opportunity to publish something or present something that has a success, but it also tells people what the process was that got you there.
Thanks, Anne. Jeb or Lucky, you're unmuted right now, so maybe I would go with you first.
Oh, I had unmuted myself, sorry. Yeah, but yeah, in general, I think what you're asking is a very difficult problem, because most people gain their impact through success. And no, there is very little incentive to put the amount of work that you need to do to publish anything, to report something that is not going to be ultimately, it's not going to have the impact that anybody would like. So if anything, we have to look at changing the incentive structure. So it's not just about getting the publishing out there, but making sure that the incentives align, to be equal to the amount of effort that you would put in to publish a successful study. So the kind of idea that Anne talked about is great, because the incentive is already there to publish your success. And if you ask people to also talk about the failed attempts that got them to the success, that sounds like an amazing approach.
Thanks. And Jeb?
Yes, I think it's, failure is how we learn. And so it's unfortunate that that's penalized in a lot of these formats. And so, and if you can learn from other people's failures, that's even better. It's one of those things that, how do we get those out there? How do we get more people aware of what worked, what didn't work? I think we had a very healthy conversation in Slack earlier this week, because somebody mentioned one of their failures in their closing slides. And it was, a lot of people were interested, why didn't that work for them? And it brought up a lot of great conversation. And so I think encouraging people to discuss and get failures out there, whether it's your best failure moments or things like that, not shun it, not put pressure on it, but I think somehow making it, I guess what I'm trying to say is that there's often people are maybe embarrassed by failures, or they don't want to talk about failures because it might impact funding. But I think we really need to find ways to encourage it and get that information out there, so we can continue to discuss it and find out why these things are failed, and understand it. So I like Anne's idea of the multiple studies in one paper. I like the idea of maybe even just like showcasing your best failures, at workshops like this might be an option. So how do we encourage people to really take ownership of these failures and be proud to share them? I think it would help as well. So
I think Jeff read my mind. I was trying to suggest maybe next year's workshop, we should have specific session that inviting people to share their failed attempts so the audience can learn from that. And I see people are nodding their heads, but maybe I will turn it to Julie and Rose to maybe if you have any additional thoughts you want to add beyond what you already shared in the last question.
I thought you were about to tell me to talk about something that I tried that failed. So thank you for not doing that. I don't have additional thoughts. I already shared mine.
Thanks. I learned that to not call out to ask people to share your failure. So
I actually love what Jeff said. I fully support that idea that maybe we start shifting the conversation or shifting the culture, I guess, to make space for those failures and to talk about how we can learn from them. I think the other thing is, I think about how we shift culture in a lot of ways and how now it's much more common that it's not just about your currency isn't just publications, but it's also data sets that you create or instruments that you create to collect data. This is popular, especially in the social sciences where we've developed surveys or instruments and that you get credit for that. So maybe it's about somebody taking the initiative to create a way of cataloging those failures or something that has been tried and that didn't work for some reason, just like you would if you did create a data set or some way of training data or an instrument. So maybe we just need somebody to write a proposal to start developing a sort of a database or a resource where that kind of information can be curated.
Thanks, Julie. And Lack, yes, go ahead. I see you have.
I was just going to say that I just went to Slido and there's a lot of questions there. So maybe we should do them rapid fire.
What we can do is go back to the workshop, the Slack channel, because yesterday that Anne and Amy and Jason did that. So basically we can move the unanswered question to Slack to answer those questions as well. So I do want to just jump into Julie, what just mentioned that about how we give people the credit of sharing data, sharing the workflow, and sharing the software and things. So I just want to call out Earth Science Information Partners, our supporter, and who are doing an amazing job of creating guidelines of how to cite data, cite software. And if you need guidelines of how to doing that and give people the credit who are making your research possible, please check out the guideline from ESIP. And Rob, I think you can take another question.
Sure, that's actually a brilliant seg to this one. And Lack, I love the idea of rapid fire through these questions, but they're good ones and we wouldn't make it through them that fast. I think the Slack is a great place. We can really have a dialogue with our audience there. So segueing from the ESIP comment there, I'm going to read this next question. Interdisciplinary, need more coffee today. Interdisciplinary research means that researchers will be using data from outside their expertise. For instance, an oceanographer wanting to start including satellite remote sensing data in her machine learning models. How can we help her get started and what resources do we need to provide?
This is actually directly relevant to a project I'm working on right now and specifically with satellite projects. And I will say it is a lot of work. I understand the amount of work that gets put into these data sets and making them available and everything like that. But the ability to access more like very 101 level resources would be just a huge help to being able to, and it is work to generate those, but because some of these can be fairly arcane if you're coming from a different field. And so just like what the different polarization modes mean, what hardware this is captured on, like really basic stuff, it can be really hard to find.
So I will jump in and say yes, absolutely. That is a huge effort. And I want to just plant a seed. One of our team members, also someone super active helping the workshop, is Tyler Christensen, who's working with Douglas and an ESIP cluster on AI ready data definition. We have a goal to get to an 80% version of a metric for NOAA by the end of this calendar year, so we can start to move forward on how do we create data sets that can enable the things you just talked about, Rose?
In industry, there is this push towards creating what are called feature stores. These are semantically defined explanations of data sets, along with a very standard way of accessing them and incorporating them in AI models. So, if we're thinking about, we're not just publishing data, but we're publishing data in a very usable form. One way to think about it is whether to publish, say, satellite remote sensing data, because we say the oceanographer is going to use it, but in reality, they're not. The way that they're going to be using it is going to be very similar to the way that hundreds of other researchers use it anyway. And so, publishing that as in a feature store would make this extremely straightforward, because it would be like any other data set that they're accessing.
That makes sense. And so my ad earlier was feel free to, and thanks, Lack. That makes a lot of sense. Feel free, anyone on the panel and listening to the audience, to reach out to Tyler or Douglas on the topic of AI-ready data. It's not only for NOAA. Our goal is to work across agencies, across sectors, and hopefully ultimate goal, get to an ISO, if that's something that's possible, with on-ramps and mergers to analysis-ready data.
I'd like to do a quick follow-on to what people have said, Rob. I mean, so one thing is the idea of standardization and making toolkits available and those kinds of things. There's a lot of that going on in this general interdisciplinary domain. Another thing is the social life of information. As we've mentioned in the development cycle, you need to be able to talk to people. So just going over to talk to somebody who works on those data and something can be a huge help, well beyond any kind of standardized advice or tools.
That's great
when
point.
we're meeting people in person again.
Yeah, and I forgot to say, Anne, earlier, I loved your comic of AI unexplainability in your slides. That was awesome.
I have that posted on my cubicle.
Great. Douglas, you want me to take the next question, or would you like to?
We have 10 minutes, so we can take one more question. Rob, if you want, go ahead.
Yeah, this is, let's see, let me look over at Slido. Give me a second here. Well, I'll just pick the next top one, and it could be tricky, but we'll continue the discussion, of course, in Slack. It seems that we are stuck with the term intelligence within AI. Oh, here we are. It moved to order. This term leads to some raised hackles among many potential non-technical users of AI products. How do we better communicate the value of AI and integrity of AI, despite some pejorative connotations of AI taking over? Branding, how do we work around that? Who wants to jump in first?
It is interesting how, AI, machine learning, it's a lot of advanced statistics. It's not magic, but it does have a lot of connotation about intelligence and taking over things. And so, getting past the hurdle of people are scared of it, it's a black box, the aspects of what's going on inside. So I think this, to me, ties back to that explainable AI parts. What is going on inside our models? What is the data that's used to create that? There's a lot of different aspects of explainable AI that can help us treat that intelligence. Maybe we don't call it explainable AI anymore because it's got that intelligence aspect.
I totally agree with Jeb here. The whole problem occurs when it doesn't work. Once AI starts to work, all of these problems go away, right? If I had come to you, like any of you 15 years ago and said, 15 years from now, whenever you want to go to your grocery store, you're going to basically speak to this robot and you're going to say, I want to go to this grocery store. It's going to show you all the available grocery stores around you. You're going to pick the one that you want to go to. And it's going to map out the exact road you're going to take. It's going to know the traffic around, and it's going to basically tell you the cost of gas at that gas station near the grocery store. You would have said, oh my God, AI is taking over my life. But yet we use it every day. It seems very friendly, and we're perfectly okay with it. And that, I think, is essentially it. Once things get to the point where they just work, all of the technology that gets you there pretty much vanishes, right? You don't really think about the technology anymore. You think in terms of the outcome that it basically gets you. So I would not worry about it. A non-technical user doesn't really care that there's AI built into it.
I think that's concerning that technology would disappear, because it can be wrong. It's not a person. It's just, it's doing its best within the particular context that it has. So in that sense, from the end user perspective, particularly regarding failure, I think that AI as a term is not really helping us. I think it's really great for marketing, but I think that we get really tripped up because social scientists, tell me if this is incorrect, but my understanding is we don't even really have a working definition of intelligence in humans. So saying that, we've accurately replicated this with this statistics is challenging to back up in any sense. So I guess I would agree that it's a term that, while it has its uses, it also causes us problems for sure as a field.
I think Anne just unmuted, but then I'll go after Anne.
Okay, I was just going to say,
a hot button question.
Yeah, we have a lot of working definitions of intelligence, and it is highly debated. Especially, it's been very publicly debated in the context of, for example, criteria for getting people into school and that kind of thing. And as you know, it's been a source of debate in society because it's exposed some of our deep-seated structural biases. So, yeah. Maybe the point is that AI is human, right?
I apologize. I meant a universally agreed on definition of intelligence.
Yeah. But that is true of any method that we use, whether it is a set of rules, or whether it is intelligence, or whether it is we flip a coin and we decide what to do. I mean, that part is true of in any guidance. Even if we had this personal forecaster that we can phone up and ask them, and they will tell us this completely personalized contextual forecast, we have the same issue.
I guess the two things that I wanted to quickly say is this conversation, at least in the weather community, isn't new. I mean, this notion of kind of meteorological cancer has been around since the 70s, as we started thinking about the role of numerical weather prediction, right? And how that was going to change how forecasters do their job and their concerns about how it does their job. And believe me, as somebody who just wrote a paper about how forecasters use different ensemble guidance, there are a lot of opinions about whether or not forecasters should be taking the guidance as the final forecast, or as something that they then layer as a new piece of information. So I think it's just to say that these conversations aren't new, they have been going on. But I also think one thing that's really important goes back to the comments Rose made earlier, which is that I think context matters, and what situations can we really generalize to? So I think part of the challenge might be if we treat AI as right or wrong as though it's dichotomous, but it's really more like, when is it right? Or how right is it? How good is it? In what context? For what kinds of meteorological threats and other threats, or in what areas of the country, or those kinds of things, I think really help nuance the problem in the way that I think is a lot more of an accurate reflection of how good it really is.
Thanks.
Yeah. Thank you, everyone. I'll pass back to Douglas.
Thanks. I think this, the last discussion links really well to a lot of things we have discussed throughout the workshop in different plenary sessions, including the risk management for AI that discussed by Dr. Elhan Tabasi from Nice, and they have been working really hard on how we can generate a risk management framework for AI related applications. So, and the topic of who should bring the table and the inherent bias that already in the data itself and using to create models being used in different things like facial recognition, who get into a school, who get promotion that Anne just mentioned, links really well to another topic we're going to discuss on our final closing plenary, which is the diversifying the workforce. So we want to make sure the workforce who are developing the AI application is diverse enough we can identify the bias in the process of development, instead of releasing a product that get backfired because there is bias that we have not considered in the development process. So I think this conversation bring all the topics in together, and thank you for all the panelists who are joining us today. And again, please, if you are on the Slack channel, please grab the questions on the Slido and move it to a workshop, to a channel to discuss further with the participants. And thank you, everyone. And I want to remind everyone, in 15 minutes, we'll have a hackathon discussion session. So for this workshop, we have a pre-workshop hackathon. We have 4 teams going to present their results. And also we invited NOAA high performance computing program to join us to discuss their perspective on how hackathon can be used for both learning and also for development or collaboration across sectors. So bring back to the topic of integrated AI development. Thank you, everyone, and hope we'll see you in 15 minutes.
Thank you.
Thank you all.